Solving systems of linear equations by graphing. Systems of equations, a set of two equations that contain the same variables. Solution of a system of equations is an ordered pair that is a solution of every point of every equation in a set. The point of intersection on a graph. Some possible solutions may be the following. Let's say you have a coordinate plane and you have two lines that intersect. It might be, the solution might be a single point with an ordered pair of xy. For example, let's say you had this and this. The solution would be the point of intersection. However, you might have a scenario where there are no solutions. An example of no solutions would look like this. And the reason why there would be no solutions is because the lines are parallel and they will never intersect. And then another possibility might be infinite solutions. Where you have the same line basically on top of each other. Okay, let's take a look at example 1. So if we take a look at example 1, it says graph the pair of equations together, 3x minus 2. Well, remember we have the slope is 3, the b is negative 2. So I'm going to start at negative 2 and make a dot. And then I'm going to go up 3 over 1. I'm going to go up 3 over 1. And then if I want to do the same thing, I could go down 3 over 1. And then I'm going to connect the dots. All right, and then now we can do the other line. The other line is going to have a slope of negative 2 and a b of 3. So if I go up 1, 2, 3, oops. One, two, three. Okay, and then I'm going to go down 2 to the right 1. So down 2 to the right 1. 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 Alright, so now we're going to graph. And we can label this. This is y equals negative 2x plus 3. and this one is y equals 3x minus 2. Okay, part B. Explain how to tell whether 2, -1 is a solution of the equation 3x minus 2 without using the graph. Well, that's easy. You can just use substitution. So you have y equals 3x minus 2. You can substitute in y. Y is -1. X is 2. 3 times 2 is 6. 6 minus 2 is 4. 4 does not equal -1. So this is not a solution. Okay, let's look at C. Tell how whether 2, -1 is a solution of -2x plus 3. So you can do the same thing. Y equals -2x plus 3. Y is -1. X is 2. -2 times 2 is -4. -4 plus 3 is -1. -1 does equal -1, so this is a solution. Explain how to use the graph to tell whether the ordered pair 2, -1 is a solution of either equation. Alright, so all you have to do is go to the right 2, 1, 2, down 1. That point is right there in red. It is a point on the line y equals -2x plus 3. Okay, find the point of intersection of the two lines. Check by substitution to determine if the solution to both equations. Alright, so right here is the point of intersection. It's going to the right 1 and up 1. So the ordered pair is 1, 1. Okay, so we can just substitute in for x as 1 and y 1. X is 1 and y is 1. And then we can solve. Alright, 3 times 1 is 3. 3 minus 2 is 1. 1 equals 1. That's a true statement. So that's a check. Alright, -2 times 1 is -2. -2 plus 3 is 1. 1 equals 1. So the point of intersection is the solution of both equations. Alright, let's go to the back side. Alright, so we are going to graph. Well, I already graphed it for this one. So the M was -1, the B was 4. So you start at 4, and you go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Alright, on this one, the M is 3, the B is 0. So you start at 0, you go up 3 to the right 1, up 3 to the right 1. So after you graph each one, you find the point of intersection. The point of intersection is where the two lines intersect. You go to the right 1 and up 3. So we're looking at the ordered pair 1, 3. Now to see if 1, 3 is correct, you can go in and substitute into here. So for every time you see y, you would put 3, and every time you see x, you would write 1. Okay, so let's see here. If we did negative 1 plus 4, we'd get 3. 3 equals 3. 3 times 1 is 3. Yep. So 1, 3 is the point of intersection. Okay, let's look at the last two. Alright, so first we want to graph the lines. So we have negative 1 slope, and it crosses the y-axis at 2. We have a negative 4 slope, and we're going to cross the y-axis at negative 1. Okay, so let's do the first one. We start at 2. We're going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. If we want, we could go to the opposite of that, which would be up 1. That should be enough points. Alright, so let's connect the dots. Alright, let's do the second line. On the second line, we're going to start at negative 1, and then we are going to go down 4, to the right 1. Then we're going to do the opposite of that. We're going to go up 4, and we're going to go to the left 1. Alright, so we're going to connect the dots. Okay, the point of intersection is negative 1, 3. Okay, so now we can check. So with the check, we have y equals negative x plus 2. So let's plug in 3, and we have negative 1 plus 2. Well, the opposite of negative 1 is 1. 1 plus 2 is 3, and 3 does equal 3, so that's good. Alright, we can check with the second equation. Negative 4x minus 1. So negative 4 times negative 1 minus 1. Negative 4 times negative 1 is 4. 4 minus 1 is 3. 3 does equal 3. The point of intersection is negative 1, 3. Alright, let's take a look at the last one. Alright, we have a slope of negative 2, and we intersect the y-axis at 5. We have a slope of 3, and we intersect the axis at the origin. So we go up 5, go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. That should be enough. Alright, we're going to start at the origin. We're going to go up 3 to the right 1, go up 3 to the right 1. The point of intersection is 1, 3. Okay, now we can do our check. So we have y equals negative 2x plus 5. So negative 2 times 1 plus 5. Negative 2 plus 5 is 3. 3 equals 3. Okay, we can check with the last one. 3 equals 3 times 1,